Okay, today's lesson is on writing functions. So we have some tables here, and we're going to write an equation for this table. So in order to do that, you want to look and see, what do I need to do to my domain value to get this range value? And it has to be the same thing happening all the way down the table. Now, please don't holler it out. These here in the beginning are going to be very simple. There will be some more challenging ones on your prep work and later here in a minute. So look at that and think about, what could I do to the 1 to have a result of a 5? And what would I do to a 2 so that I could get 6? And that same operation is happening all the way down the table. Okay. All right, Chance, what do you think?
You can add 4.
You could add 4. 1 plus 4 would be 5. 2 plus 4 is 6. 3 plus 4 is 7. And 4 plus 4 is 8. Good. So we need to write that as an equation. So it's going to be y equals, because these are the values that we're getting, when we do what to the x? Add 4. So it's x plus 4. And that's the equation. That's what you're doing. You're looking at the table and trying to see, what am I doing to my domain so that I get this range value? Let's look at the second one. Think about what you might need to do. What operation would get you from 1 to 1, 3 to 9, 6 to 36, and 9 to 81? Olivia, thank you for raising your hand. Square it. Multiply by itself. 1 times 1 is 1. 3 times 3 is 9. 6 times 6 is 36. And 9 times 9 is 81. So we would write that equation as y equals x squared. Very good. X squared. By the way, squaring something is not the same as multiplying it by 2. It is not dividing by 2. It is multiplying it by itself. Okay, look at number 3. What might you be doing to this 1 to get here? And then the same thing is happening all the way down. Raise your hand. Harley?
You're subtracting 2.
You're subtracting 2. So we have y equals x minus 2. Very good. Okay, look at number 4. When you have an idea, raise your hand, but please do not say it out loud. Take a moment and really think through that. Okay, Mackenzie, what do you think?
You square it and then add 1.
She says square it and then add 1. 1 times 1 plus 1 is 2. 2 times 2 is 4 plus 1 is 5. 3 times 3 is 9 plus 1 is 10. 4 times 4 is 16 plus 1 is 17. Good. So y equals x squared plus 1. Very good. Very good. Okay, there will be some that are tricky, and you just have to sit there and think, what am I doing to that x value to get the y? It's possible that you might have to multiply it by 3 and then subtract 2 or something, but you just start with the first ordered pair and work your way. You know, once you find something that works, check the rest of the table. It has to work all the way down the table. And in your homework, I think some of your homework problems have an f of x right here. So if they do, instead of writing y equals, you can just put f of x equals. Okay? It's still serving the same purpose. Let's look at this next problem. It says a carpenter buys finishing nails by the pound. Each pound of nails costs $1.19. Write a function rule to describe this relationship. Okay? Let's let n represent the number of pounds that we're going to buy. Okay, so I would write that down. That's part of your answer. It's called defining your variables, telling what your variable means. N is going to be the number of pounds bought. And then C of N is going to be the cost in terms of the number of pounds bought, meaning the cost depends on the number of pounds bought. So let's start with C of N. The cost in terms of the number of pounds purchased would be, how would I write that? Well, we're going to use n, but yes. Did I say use x? No, okay. All right, if I don't tell you, you can use whatever variable you want. So C of n is equal to 1.19n. That wouldn't be any different than writing y equals 1.19x. It's still going to serve the same purpose. Okay? Now we're going to use that to determine how much 12 pounds of finishing nails would cost. So if we're going to buy 12 pounds of nails, then if n is 12, we're going to do 1.19 times 12. So on your paper, go ahead and calculate what that would be. Okay, Hannah?
16.18.
Anybody get anything different? Paula?
14.28.
Anybody agree with that? 14.28? Okay. I think that it should be $14.28. So just make sure you guys double check with your multiplication.
$14.28.
You figured it out? Yes, that should be correct.
I wrote 22 instead of 12.
Oh, that would be why. Okay, let's look at this problem right here. The admission to a Lake Wells football game is $5 plus $2 per passenger. The total the total admission is a function of the number of passengers. So that means when it says the total admission, the cost is a function of the number of passengers. It means the cost to get in depends on how many passengers go in, right? So if we're talking like independent and dependent variables, the independent variable would be the number of passengers that go in, right? However many passengers, I mean, you can change that up, and then the cost depends on that, okay? But we already have the equation right here that we're going to use, and we have to create a table so that we can graph. So let's come over here, and let's create a little table, and we're going to put n here for number of passengers, and T of n stands for the total cost, depending on the number of passengers that we have. So what is the least amount of passengers that could drive in the car? One. Okay, so if that's the case, come over here and look at this right here, and we have to do 2 times 1 first, right? Which is 2, and 5 plus that 2 would be 7. So one person would cost $7. How about 2 people? How much would 2 people cost?
14.
You have to do the 2 times 2 first, and then add the 5. So it would be 9. Be very careful. 3 people would cost 11. 4 people would cost
13.
5 people,
15.
6 people, 17, right? Okay. And you could keep going, but that should be sufficient. Now, we're going to graph this. So let's go down here to the bottom, and we're going to put at the bottom number of passengers. And then on the y-axis, we're going to put total for total cost. Okay? Now, when we label this at the bottom, we're going to have 0 here. How many did we go up to on our chart? 6. Because we're talking about people, I really don't want to go by halves because you can't have half of a person. So I'm going to just count by ones. 2, 3, 4, 5, 6. And you could keep going. I'm just going to count it out to 10. And then the cost goes up to $17. So what do you want to count by? You got to count by something. You can't just start putting the numbers on there. If you count by fives, look here. 5, 10, 15, 20. All your dots are going to be all just in this little area right here. So I would count by something smaller. And you know what? If you can ever count by ones, I would do that. If ones don't fit, then I would try twos. But I think ones do fit. Okay, and then we're going to plot the points. So 1 gives us 7, right? So we go over 1 and up to 7, and then over 2 and up to 9, 3, 11, 4, 13, 5, 15, and 6, 17. I should have gone. So you can see that it's a linear graph here. Okay? All right, let's go to the next one. Suppose a van gets 22 miles per gallon. The distance, d of g, is a function of the gallons of gas used. Use the rule d of g is equal to 22g to make a table of values and graph the points. Okay, so 22 miles per gallon. So we're going to start with going on 1 gallon, we would get 22 miles. On 2 gallons, we would get 44. On 3 gallons, on 4 gallons, 5 gallons, and 10, and so on. So what are we going to put along the x-axis down here?
Number of gallons.
Correct. Number of gallons. And then along the y-axis, we're going to put
Miles per gallon.
miles, not per gallon, just put miles. Or you know what, let's put distance. Okay, now we need to count by something. So for our gallons, now, we could count by ones, or is it possible to have a half of a gallon?
Yeah.
Okay, great. I'm going to count by half. So I'm going to let that next little tick mark right here be a half of a gallon. Every little tick mark has to stand for something. So if I go over here and I put my 1 here, I'm not really counting by ones. I'm really counting by 0.5s. Do you see that? Okay? So you have to be consistent with what you're counting by. Just because I'm labeling it using integers, I'm really counting by 0.5s. Okay, and then the money goes up to 110. So what do you suggest we count by here? You want it to try to fill up as much as you can going up the y-axis.
By 11.
11s is what we decided to use earlier today. I think that's kind of nice. That works out nice. And you could keep going up. And then plot your points. It's linear as well. Okay, then it says in part B, how far did the van travel if it used 10.5 gallons of gas? Well, you can use the equation that you had, right? Which was D of G is equivalent to 22G. So if we're talking about 10.5 gallons of gas, you could just do 22 times 10.5, right? Or could you look at that graph and continue labeling going up, and then notice the slope here? It's going up to, right to, up to, right. Notice that? And could you keep that pattern all the way up until you see the intersection for about 10.5 gallons? Sure, you could do that, right? Okay? So that's kind of the purpose of that. But if you will figure out 22 times 10.5, Brock,
231.
do we agree?
Yes.
231, what are we? 231 miles?
Yeah.
Okay, very good. Very good. Is that not what we got? Okay, let me check this. 22 times 10.5. So 10.5. Here's the work.
You gotta add a decimal point to that, so it's 231 instead of 2,000.
You got to make sure you add a decimal.
Then you come in one place, so it's 231. Yes.
Wait, what does 200?
Right, but you had to carry a 1. 5 times 2 is 10. Carry your 1. Okay, very good.